Hi, welcome to the first day of Unit 1 of the fall semester of PreCal Seniors. A lot of this unit is going to be review of Algebra 1 and Algebra 2. Like here, for example, how can we tell that something is a function or not? Well, a function by definition is when every input has a unique output. That means when you plug in a certain number, a certain y value or output should occur. So with this first thing that we have here, this is called a mapping. It maps our inputs to our outputs, which are labeled as domain and range, which domain is all our possible inputs, range is our all possible outputs. So is this a function? It is. And some of you might be thinking, well, wait, if you plug in 6, you get out 4, and if you get 7, you plug in 7, you also get 4. So how is it that the ranges repeat? Then that's fine. You can have multiple outputs as long as that single input, when you plug it into a function, so it is okay to repeat y values. It is not okay to repeat x values. What about this next thing? Well, this is called a relation. It's a set of ordered pairs. Every x has a y value. So if you look at the point 4, -2, if you plug in 4, you get -2. In the next point, we have 6 and -1, and then we have 6 and -3, which is weird because that's saying that if you plug in 6, you get -1 sometimes and -3 another. So this is not a function. X values cannot repeat. If you plug in a certain number, you expect to get something out. Here, if you kind of ask yourself, well, if you plug in 6, sometimes you get -1, sometimes you get -3. When does one happen? So that's why that's not a function. With graphs, we have something called the vertical line test, and I abbreviate VLT. So if you draw a vertical line and it hits the function more than once, like here, if I were to draw a vertical line, it hits the function here and here. So therefore, this is also not a function. It fails the vertical line test. So something else that you're going to need to do in this class for this unit is know how to graph. So we have a couple of examples of things that you have seen in Algebra 1, Algebra 2, like number 4. Number 4 here is a linear function, and I can know it's a linear function because we have x and we have y. So what I'm going to do, this is something that we call standard form. And I'll write that down. This is standard form. This is when x and y are on the same side of the equal sign. You could solve for y and get it into slope-intercept form if you remember that from linear functions of Algebra 1. Or what I like to do is I like to find the x and y intercepts. The x-intercept you get if y is 0. So if you plug in 0 in that, you get left with 2x equals 6, so x equals 3. That means you get a point at 3, 0. So I'm going to plot that point here. Well, the same thing for the y-intercept. If you plug in 0 in for x, you get -3y equals 6, so y equals -2. So you end up getting a y-intercept at 0, -2. Well, to draw a line, all you need is 2 points. So I'm going to try to do the best I can on here to connect those 2 points. And there's your line. Is this a function? Well, I kept saying it. It's a linear function, so yes, this is a function. Every x has a unique y. There's no x's that repeat. Then we're going to kind of remind you about domain and range. Domain is all possible x values. So you ask yourself the question, are there any values of x's that I cannot plug into this? No. So there's a couple of ways that you can do this. You can use the script R, that's for all real numbers, or you can say, using interval notation, -infinity to infinity. It's up to you. Pick one. If you like interval notation, that's fine. If you want all real numbers, that's all too. And you can even write out the words all real numbers. Range are all the possible outputs, y values. So if you notice this graph goes all the way left and right, which is domain, and then all the way up and down. So there are no y values that don't come out. So we can also put all real numbers or -infinity to infinity. And again, you choose which kind of method do you like to do here. Then number five. So number five, what I'm going to do is I'm going to move that positive 3 over to the other side so that it can be y equals. So y equals negative absolute value of x minus 3. Now, if you remember your function transformations from Algebra 1 and Algebra 2, you probably know what this graph looks like. And it's also something that we'll do later on in this unit. But since we're just first starting out, the easiest thing we can do is just plug in numbers. And the way you plug in numbers is very important. So you have to kind of pay attention to x values. I kind of gave you a table here already. So if you plug in negative 2 into the absolute value, you get positive 2. However, that negative on the outside still keeps it negative. So now we have negative 2 minus 3, which is negative 5. Plug in negative 1, get positive 1, but the negative still makes it negative. Minus 3 is negative 4. You plug in 0, there's no such thing as negative 0, so 0 minus 3 is negative 3. Then plug in 1, you get the absolute value of 1 is 1, but then it's still negative, so negative 1 minus 3 is negative 4. If you plug in 2, you get negative 5. So I'm going to plot all those points. So 0, negative 3, negative 1, negative 4, and then 1, negative 4, and then 2, negative 5. So you end up getting a graph that looks something like this. That's the absolute value function. That's a graph that you should know what it looks like from Algebra 1 and Algebra 2. So this is a function. If you notice, we plug in different x values and we get y values out. Some of the y's repeat, like you can see on the table, but it's okay for your y values to repeat. So I'm going to put that as yes. Now, what about my domain? Well, I can plug in any value of x that I want to. So I'm going to use the script R because it's just a lot easier to write. However, if you notice your graph, it starts at negative 3 and goes down. So it's all the values of y that are less than or equal to negative 3. So you can either write that in words, you can use inequalities like this, or if you want to, if you like interval notation, it's negative infinity to negative 3 with the square bracket. Something from Algebra 2 that you should remember. I'm a really big fan of inequalities, but you choose one or the other. Now what about number 6? Notice that the absolute value bars are on the y. So here, instead of like the last problem I solved for y, I'm going to solve this one for x. So I'm going to add 3 to both sides. I'm going to fix that y. I almost started writing an x. And notice the table. The table of values that we have, I don't know what this extra thing here is. Okay. I have a table of y versus x's. So in this situation, since we have the absolute value of y, we actually need to plug in values of y in to get an x out. So that kind of changes our input and output. So that kind of brings up a kind of thing that we're going to talk about in a little bit. So what happens if I plug in the absolute value, or plug in negative 2 into the absolute value of y? We get positive 2 plus 3 is 5. Then you plug in negative 1, you get 1 plus 3 is 4. Plug in 0, you get 3. Plug in 1 in for the y value. The absolute value of 1 is 1 plus 3 is 4. And then 2, 5. However, if I'm going to plot this on this graph that's still x, y, I'm going to have an x value of 5 and a y value of negative 2. 4 and negative 1. 3 and 0. And then 4 and 1. And 5 and 2. So you end up getting a graph that looks something like this. So if you kind of heard me earlier when I said that y is now our input and x is our output, that kind of changes things up a little bit. So is this a function? No. Because now I have to plug in y values to get out x's. Also, you can apply the vertical line test if you draw a vertical line at least one place on this graph that hits it more than once. It's not a function. Still, by definition, domain is all the inputs or the x values that we're talking about. So since our graph is still x is horizontally and y's are vertically, our domain is talking about how far left and right does the graph go. Well, it starts at 3 for the x's and gets bigger. So our x's are going to be greater than or equal to 3. Our y values, however, it's all the way up and down. There's no y value that ever doesn't come out. So that is going to change our range there for that. Then this next graph, if you notice, you have x squared plus y squared equals 9, which is not a linear function. This, if you remember from Algebra 2, is a circle. This circle has a center at 0, 0. And this 9 here is our r squared. So if we square root both sides, we end up getting that the radius of the circle is 3. So it's just easy to just go right 3, up 3, left 3, and down 3, and try to do the best you can to draw the circle. Well, are circles functions? No, because if you apply the vertical line test, you hit the graph more than once. The domain, however, is all the numbers between -3 and 3. So you can see that a graph doesn't go past -3 or past +3, it's everything in between. So it's up to you how you do this. This is one where I think interval notation is a little bit easier to write. So -3 to 3, it's always least to greatest. And then the same thing with the y values. They're all stuck between -3 and 3. And they're square brackets since we're including those numbers. All right, the next thing we're going to talk about in these notes is about the interval in which something is increasing versus decreasing. So we need to always make sure that we are doing this from left to right. That's how increasing, decreasing works. You're talking about as x approaches infinity. It does not matter where the arrows on the graph is going. We need to read this from left to right. So like if you were to be tracing this graph, like from left to right, you would be going here, and then you would be going this way, and then you would be going this way. That means that our graph is increasing all the way from from the left, which is -infinity, until it gets to -3. So my interval of increasing is going to be -infinity to -3. This arrow that we have on the graph here does not signify anything about the graph increasing or decreasing. We're talking about as x goes to infinity, what is happening to our y values. Here, our y values are increasing. So where does this decrease? Well, it starts decreasing at 2, and it just keeps decreasing forever until it gets to infinity. When is it constant? When is it all the same? Well, if you see that horizontal line, it starts at -3 and then goes to +2. So these are intervals of x's that is showing where our graph is increasing, decreasing, or staying constant. Some of you might be asking, well, why didn't I put square brackets at -3, 2 on either one of those? Well, at a certain point, I believe that a point is neither increasing, decreasing, or neither constant. It's just a weird thing that happens at a certain point, because when we're talking about increasing, decreasing, we're talking about as x gets bigger. Where is a function positive? That's what this is saying. Where the y value is positive for f of x is greater than 0, and where is it negative? So I'm going to put a note here. So positive y's and negative y's. So positive y values is when the graph is above the x-axis. So I was going to use a highlighter. So here, here, and here is where my function is positive, where my y values are positive. So all of these answers are going to be the x values. So what x values create or make this function positive? Well, it's all the numbers between -4 and 3. Now, 0 is a number that's neither positive nor negative, so that's why we write intervals with parentheses and not square brackets. Where is this function negative? Well, where is it below the x-axis? Well, here and here. So we talk about the graph going like all the x values that are to the left of -4. So that's going to be -infinity to -4. And then it becomes negative again at +3, and it goes all the way to the right to infinity. And we'll put a little union sign in the middle of that to unite those two intervals. Now, what about this next one? So again, we want to read the graph left to right. So it's going this way, and then going this way, and then it goes this way. So It's increasing when that arrow is going up, that green one that I drew. And I apologize if you're colorblind, but that first arrow that I drew is increasing from negative infinity and stops increasing at -1. But then if you notice again, at +1, it starts increasing again. So we have two intervals in which it's increasing. When does it decrease? Well, that green arrow that I drew down in the middle between -1 and 1 is when it decreases. When is it constant? When is it a horizontal line? Well, never. So it's never constant. Where is the function positive? Well, again, that's where it's above the x-axis, so here and here. It's negative down here and down here. So we're going to write two intervals in which the function's positive. So where is it above the x-axis? Well, the x values are from -2 to 0. But then it becomes positive again at 2 and goes all the way to the right to infinity. When is it below the x-axis? Well, all the way to the left, which is -infinity to -2. And then back again at 0 to +2. That's where the function is positive or negative. So just pay attention to these intervals. These intervals are always intervals of the x values, so make sure that you're paying attention to that. If you have questions, please let me know. Make sure you do your assignment.